Hello and welcome to Data Science in Primary. My name is Melinda and I am very excited to work with you today. I am the editor of Creative Educator magazine. It used to be in print, but now it's completely online, and we work at Creative Educator to make big ideas in education accessible and exciting. Now, again, my background and my focus is creativity and project-based learning. I used to be a PE teacher, but that was a very long time ago, and I've been training teachers since the mid-90s. I really want kids to be making. And so in data science, this is a fun one because I think so many times we underestimate, and maybe not the teachers who teach them, so kudos to you, but we underestimate our youngest learners. And so maybe we're not doing the entire data science process or looking at it in the way that you might in college, but we're still building essential foundations for that. So I think that's really where I should start. And that is sort of what is the idea of data science. And to really put it simply, it's how looking at the study of how we gather and use information to solve problems and understand our world. Doesn't that sound like kindergarten? 5 senses on those. So there's a lot of things that you're going to find, and I think I'm just going to be sharing a lot of ideas that you may already do, but hopefully when I talk about them in a data science sort of mind worldview, is we're looking at the questions we need to be asking our students and the skills that we need to build as we're doing some activities I think that we already do. So let's start with the data science process. And as you can see, this is a cyclical or recurring process. You can jump around in it. And so really, I think most people think about it begins with us developing and asking a quality question. And then we are going to, of course, think about looking to data to figure out the answer to that question. So obviously, I'm going to ask my question. Sounds a little bit like the scientific method too. Then I am going to collect and visualize data. Now, when I do that, I may decide I want to ask a different question, even if I'm just barely starting. So it's not like we can't go around that. But again, within this process, we're looking at sort of all the skills that are going to take us full circle through this. And then I will talk about hitting them discreetly. So we're going to collect our data. We're going to maybe work to visualize it. A lot of us might be thinking data science, infographics, and that kind of thing. And I think that's where it sort of comes to the fore, because so much of it, our world is surrounded by this phone and there's so much information. How do we make sense of it? And that's where so much of this data science came out, as we have the capabilities with citizen science and access to databases, and now AI helping us cross multiple databases and find information. What are we going to do with that? And that's sort of, I think, the key. That's why I think there's such a great focus on data science now, because it's such an essential skill in our world today. So when we look at that data and we visualized it, we're going to look at it and we're going to see, can I see a pattern here? Can I find some repetition? Is there something that's pointing me in a certain direction, to be able to then make a decision using that data, whether it's change my behavior, implement a new solution. I also have to be able to communicate that information. And again, I might communicate it visually through an infographic. I might utilize the way I visualize that data, but how am I going to share it so that if it not only informs my decision-making process, it informs others as well. So sort of big picture of the process, and I want to talk about some of those pieces and what we can do with our students. And I think we do this already. One of the great things we want to do is when we ask a question or we start this process, we gotta have to maybe have a guess or hypothesis about what we think might happen. And then we can experiment or collect data to see if it reinforces that, whether our viewpoint or our hypothesis is correct or not. And again, data is a lot of facts. We're working with that. So, if you have that, that jar of jelly beans, or fill something with nails or paper clips, how many do we think are in there? Let's take it apart and count it. That's a wonderful example of very early grades doing some of that building number sense, but also, again, making a prediction about size and space and measurement. We might do something like that with a photograph. In this case, I can look at that meerkat. I know that they're meerkats. My students might not, and I might want to do something like an I see, I wonder sort of worksheet. And I've uploaded one of these to the conference site if you want to print it out and use that with your kids. But again, not everybody can write with that. But what do we see in that? That's, again, it's sort of like that scientific method. I have to be able to make observations and then come up with my questions based on what I'm looking at. So I might look at that and go, well, there's furry animals. I can see ears on them. They appear to be in some sort of log, maybe in the grass. I'm thinking it's grass because it's got long stems. And this is a teacher, they're making observations and going to ask a question. But my biggest question is what are they looking at? Are they all looking at the same thing? What has their attention? And so we're sort of getting that, maybe doing an I see, I wonder, and hopefully, again, when kids are filling out that I see, I wonder, they can formulate those questions. With the younger ones, maybe we're not doing this individually where they're writing on that because it might take too much time. And if they're just emerging writers, they may not be capable of that. So I'm going to put it on my board at the beginning of class, or my whiteboard, or project it somewhere. And then we're going to sit in our circle time. And, what do we see? We can do that as a whole group. Same thing with I wonder, what sort of questions do we have? And this is the best part about data science. And what I love about making our classroom student-centered is so often as a teacher, we're the ones asking all the questions. And we really, if kids are going to be powerful with data and information in a world that's changing, they have to be able to learn to ask questions. And this I see, I wonder is letting them know that we would like them to be asking those questions and doing those prompts. This is something also that a lot of people do, is coming out of the Reggio Emilia I think it's called provocazione. I don't know how to quite say that, but it's sort of a situation. And rather than, I'll leave the definition up there for a half sec, but I'm giving my students an experience or something like that photo. What am I showing them that is going to make them think about something and wonder? Because it's that wonder that they're going to start asking questions. A lot of us do this by raising monarchs in our classroom. We might be having a trip to a farm, or being able to pet an animal, describe to me what it feels like. But again, so often when a student is with it, what does that feel like? Do you like it? Is it soft? Why are we asking all the questions? You can slow down and do that. Let them play. This one, I don't know if you can see the two young boys in there. They are actually, this was just a bark area at school and some leaves had fallen in it, and they started making nests. And so it was really fun. All the kids then started to build these different nests, and then they started to imagine what animals might live in them, how might be different sizes, how many leaves are, and they start having all these questions, and they do these other things, and it's letting them get to some place that's interesting and let them take it in a direction that they want. Because again, especially with data science, it's not the answer. It is about the process. How well can we ask good questions? How well can we make those predictions? How well are we collecting and analyzing that data? How well are we communicating it? So the content of it is less important. So apply it wherever it makes sense within your curriculum, because it can be applied in a lot of different places. It's not just sort of a math thing. I think it's a lot of a great one with science. Let's imagine we go on a nature walk. We can't collect data if we're not paying good attention, if we're not being, attend to precision to be able to see that. But it might even be something, I just did draw and write 4 plants on that. So again, we're practicing some of our early literacy and our phonemic awareness skills. We're practicing visual representations of information. In this case, they collected all these things that they found on their nature walk on the ground, and then just asked them to sort them and put them together. And we just did that on the sidewalk. I think it was brown, white, green, and color. Oh, I think that was colorful with that phonetic. I think I can make it a little bit bigger to read those a little bit better. So they identified how they sorted it. Again, sorting is less important to be a right answer as for us to be able to listen to their thinking behind how they're sorting. Because again, that's the data. I have to be able to see things that are similar and different within data so that I have a sense of what I am supposed to do with that. And again, I could go back to that I see, I wonder. So sometimes we want to do, like, observation is the foundation of the scientific method. So sometimes we might need to do something like this or do our provocation before we can go back and make a prediction, which might even be something like, you see the colorful things, kids we could ask them, well, what do we think we would see on the ground in the fall? What do we think we might see on the ground in the winter? And then having them make those predictions based on what they're thinking about this. And then we can, how do we test that? We'll do another nature walk and go through and collect our data over the course of the year. Similarly, again, we have to be able to I mentioned a little bit of that compare and contrast. How are things similar and different? We're doing sorting. We're classifying objects. We do that all the time in those elementary grades. And here are just two examples that on a piece of paper where they're highlighting, and I think these are in a computer program where they can click and drag, but even something in science. Things that move and are alive, those Venn diagrams, every time you do that, we're sorting and classifying. It could be a whole bunch of, pour a bunch of rocks in there, pour money in the middle. And again, recognizing which things are the same, which are different, and finding an attribute with that. And again, asking them back to that nature walk, explaining what the attribute is that makes them do that classification. Because we're starting to do some of that again. We're leading ourselves into that analysis piece of this. So again, we're also looking at, we can't do any sort of analysis until we've done something with the data. So all of those fun things we do, maybe again, as our more part of our morning routine, we might have a daily tally, 2 books, which is your favorite book, put your tally mark in there. Then we're going back to doing all of those basic math skills and number sense. Let's count each of those tally marks. Let's total them up. And again, for more advanced students, does this total to everyone in the class? We might represent it visually with a bar graph. And so all of those things are also skills, basic skills that are doable by very young students. And I think that's the fun part in here. And I don't think this is interactive. But sometimes you have graphing programs where you'll see, like, this is just, what's your favorite summer treat? And I would, I could fill it. I could tap it and fill it with a paint bucket. I could color it on a piece of paper. I could have a big graph on my whiteboard in the morning. I could have them drag squares or paste sticky notes in where it fits. I could have them color code the sticky notes. There's all sorts of, again, right ways to be able to do this, but it's sort of almost the would you rather fun thing in the morning. And I think I might even have that somewhere else as we're getting them to think about different ways that we can work through our data and look at that. And again, so again, part of what we're doing with data is they have to make sense of it, not just represent it. And we're really looking for them to identify patterns in this. Wait, why are all of these, and eventually in my line plot, why are there a whole bunch of outliers here? Or wait, look, all of those things follow a general trajectory, even though my dot plot are all over, there is sort of a general through line. Again, we're trying to get them to visually see that. Young kids, algebraic thinking too. What are the patterns here? It could be a coloring activity. It could be, again, finding something that my kids want to do. This is one where they're dragging stickers on a page to make a pattern. But again, take money on the ground, any sort of, objects that you can have where they can work on and where they can move things around. And I have some more printables in a data science article on Creative Educator. If you look in the resources section, there's a data science kit there. And I have another sort of one here too, where you can look at that. But any sort of patterning activity. And again, that's a wonderful one for math. That's pre-algebraic skill. But that is also a data science skill because I have to be able to see those patterns in numbers and or the data that I'm looking at in order to be able to analyze it, because I want to be able to make a prediction. Because again, if I'm going to make a decision, I have to be able to predict what's going to happen there. And the more I can be accurate about that, the better my decision making will be. We could do this also with recycled materials or materials that we pull out of the waste bin. This is a whole bunch of different kinds of lids. And some fun parts about this is the kids did them, again, in 2 dimensions and then that tangible space on their desk. And they were making patterns here. But when I go on the computer, I sort of have a sort of like, I love this, the Dr. Olds calls it abundance, where I can just work with more and more and more things, which sort of frees up my mind to try a lot of different things. So they took a picture of the patterns or the design that they created on the ground, and then on the computer, they made it into what they call a pattern play piece. And then they took that piece and they just, lined it up. And then wait, if I flip it, what if I size it? What if I flip it this way? How long and essentially that's the fun part, that pattern can extend infinitely. So now we're not just looking at linear things, we're looking at things in 3 dimensions. And this is a fun one, a nice quote from Dr. Old: attention to possibilities leads to intention for possibilities. And that's sort of, again, that predictive piece. And that's also how we foment and create and support creativity in our learners. So again, that any sort of patterning, and there's 1,000 different right ways to do this, and you probably do a lot of these things already. And again, something as simple as coloring the things on a train, coloring balloons in a row, flowers in a row. Kids can have them draw something from scratch, create the pattern. It could be on a blank piece of paper with crayons, pencils, objects. There's you put kids, see if they can find a pattern with different students in their classroom, tall, short. Colored clothing, stripes or solids. Another one is finding patterns, and this is sort of, again, branching out, but we're still getting kids to see the pattern, is we read them all sorts of great books that have pattern stories in them. It Looked Like Spilt Milk by Charles G. Shaw. This is one of my favorite ones with the really little guys. I'm going to open up this example, and it's a book, so it's a little bit harder to see, but hopefully we can hear it also.
Sometimes it looked like spilt milk, but it wasn't spilt milk. Sometimes it looked like a heart, but it wasn't a heart. Sometimes it looked like a fish, but it wasn't a fish. Sometimes it looked like a snowflake, but it wasn't a snowflake. Sometimes it looked like a butterfly, but it wasn't a butterfly. Sometimes it looked like spilt milk, but it wasn't spilt milk. Just a cloud in the sky.
It was just a cloud in the sky. So I don't know if you've ever read that book by Charles G. Shaw, but that's what sort of, it's just blue background, white. And so I like to do this, and that was an example. We had done it in individual students in the class. I put it on the whiteboard in the morning, and they came in, and I just had a blue background. I took the eraser tool and erased a shape to white. And then there was, in fact, you could see that pattern. Sometimes it looked like blank, but it wasn't blank. And so again, getting them to do some of those basic words, I'm setting up the sentence structure for that, but to be able to see the pattern. And I put the music notes there because we do this with nursery rhymes or the songs that we sing that repeat over and over again. Head, shoulders, knees, and toes. We're teaching them all these things again by that repetition, but getting them to see that pattern and make that prediction. And there's a book, Mary Wore Her Red Dress. It's a Southern song. I think a common one in some of the younger grades might be listening to it with Rafi. But we did the same one. And again, this one is a pattern. So if we go here, we'll see, listen, it's the same child.
Aspen wore her pink dress, her pink dress, her pink dress. Aspen wore her pink dress all day long.
She sang it. Not every kid had to sing it. But again, you can see the pink dress, pink dress, pink dress. We're learning our colors and our clothing vocabulary. I think she just...
Kalina wore her green dress, green dress, green dress. Kalina wore her green dress all night long.
And she said night instead of day. Kalina likes to be different. And she did this one, and then she didn't like it because she wanted to have something black on. Again, to be a little bit more different, to showcase her unique ability. But again, so the fun part is every student looks a little bit different. They pick their whatever clothes. You get a little bit of sense of personality, but there's that pattern, that repetition that they do. And so for those younger learners, we use pattern stories because it makes it easier for them to make a prediction. And so when we're reading the Spilt Milk book, and the teacher did, everybody did their own, and then she sent it home, and all the kids were reading it. And they were, I think this was a preschool project. And so by the time, they all know how to read it because they can look at the picture. Sometimes it looked like I'm going to guess heart, but it wasn't a heart. And then you can hear, she obviously, by the time she made her own version, she had heard that over and over again and was starting to get intonation and be able to share that. But that pattern allowed them, and it gives them that confidence to be able to do that. So it is getting them to see that when you're reading stories, what is the pattern here? If you can find that. And I'm trying to think, again, on Creative Educator, there's a list of story adaptations and a lesson plan for creating all sorts of different pattern stories, some fun resources with that. And so again, you might not think about language arts with data science, but there's a lot of language arts in that because one of the biggest things we have to do is be able to communicate our findings. And I apologize to anyone who went to the data storytelling one, because I brought up this book in it, and that is Five Creatures by Emily Jenkins. And so you can kind of see the five creatures in here. There's a family, a mom, a dad, a little girl, and two cats. And so if we read the story, she tells me data about each of those things and gets the whole group here. So I don't know if you can see that. In my family, there are 3 short and 2 tall, 4 grown-ups, 1 child. That's me. 3 with orange hair, 2 with gray, 2 with long hair, and 3 with short. So again, all the different ways that we can add up to 5. So not only is giving us flexibility with numbers, flexibility with how we think about that, so our students are able to, oh, and I forgot this one, kind of think automatically goes through. So it's going to start, and I'll see if I can pause it at the next one. Here we go. 8 creatures live in this house, 4 humans, 2 dogs, and 2 lovebirds, 2 grown-ups, 1 sister and me, 4 with dark hair, 1 with blonde hair, 2 with green and yellow feathers. So we're not going to do this sort of like make your own 5 creature story with really young kids, but it's that same kind of data storytelling as we're trying to figure out how do we share data in a way that's enjoyable for people to learn? How many different ways can we share the same level of data? I love this one too, because it's a wonderful beginning of the year, especially for older students. As you know, the kids, even in middle school, they love it when you bring out the picture books, especially if they've read those as a kid. They remember a lot of that. So in this one, there are 5 students learning in this group, 3 with dark hair, 1 with blonde hair, 1 with red hair, and then 2 on the dance team, 3 play soccer. Another one, all love cookies. So again, so it's they have to, and I actually have a table, so they have to pick an attribute and see who, they have to name all their team members and see who on the team shares that attribute. Mix up with color, might be hair color, it might be what kind of clothes, what sport they play, what food they like to eat, favorite foods. It doesn't matter what it is, because really in this case it's an SEL project. We're getting them to know each other, and we're using data. Oh, because wait, data informs. Data gives me information about someone, and can help me go through that sort of work and get them excited about that. But really, the point of doing data science is that we're looking to use data to make better decisions about how we live, how we spend our money, how we can take care of our environment. There's a lot of different, how we choose the next book to read. We want to have information. And so again, I shared that tally example. What's your favorite summer treat? Well, what I might want to do with that is, okay, I might ask this in May. And then when we have our class party, we're going to look at, okay, if we wanted to pick one, now, of course, if you're working with the younger kids, they're only going to want what they want. But we're going to talk about, if I wanted to make the most people happy, I am going to choose to do ice cream, because the largest number of people like that. So this is how we're going to make a decision with a tally that way. But I mentioned the would you rather idea. And so again, a fun way to play that. Would you rather sneeze glitter or burp bubbles? And so again, I'm going to ask kids, not just, they make their choice, but then I'm going to ask them why they made that choice. Because again, already by making a decision like this, I'm going back and thinking about, well, what does it feel? Do I like to sneeze? What about burping? Well, so there's all these choices. So they're actually in their heads collecting and working with that data on their own to kind of, again, make that decision. And being silly like this is a way to do it without it having to be, I have to make a decision about which house to buy. That's, again, they're not going to do that for a very long time, but they need to be able to learn how to weigh the information that they have, to balance that, to put it in a way they can visualize. Am I going to use a spreadsheet? Am I going to take a tally chart? Am I going to do a pros and cons? Lots of different ways to work with that data. And again, data science is a whole lot more complex. And again, this is another way to sort of maybe prompt questions in that provocation, but maybe with older students. And would you rather have a quail or a nudibranch as a pet? Okay, well, number one, I would hope some kids, there probably is one in every class who knows what both of those animals are, but I picked 2 that might be a little bit more difficult. So, okay, well, so I can't answer that. I can't make a decision because I don't know what those things are. So now again, it prompts kids to want to know, to want to collect the data. Funny, research is collecting data. And so again, part of that is, informational data. Data doesn't have to just be numbers. I think that's where we're headed with data science. And what we want to do is to get them, have them have facility with those kinds of things as well. But there's so many different ways that we can use that process in so many different subjects. One of the things that I'll share here, and if you want to grab that QR code, and I have a link to it, I think also in the description of this, is a fun project that is working with the artist Pete Mondrian. And you might know him. If you see those squares in the picture there, you can recognize a lot of his art that way. And so what you have kids do in this is they learn a little bit about Pete Mondrian, and then they just do a coloring page. But when they're doing the coloring page, they then have to count up. How many squares did I choose to do blue? How many did I choose to do yellow? How many are big? How many are small? How many are rectangles? How many are squares? And they add and tally all that up, and then they look at a friend's. And so as they're doing that, now I'm looking at that. I can validate whether they collected their data correctly about how many of each of those things are on their sort of data sheet about that. But then they're also learning to communicate. And specifically, I think there's a kindergarten standard about location, above, below, larger, smaller. I'm being very descriptive about how I am identifying, collecting my data, and doing that measurement. And then, of course, this can also be an art project, and then they're going to use lines and colors to create their own sort of Mondrian-inspired art. So a fun way to be able to do that for very young students. It hits a kindergarten standard, and it sort of does that whole data science process throughout the entire piece of that. So again, that is me, Melinda Culp. You can follow me on social media at Creative Educator. And then there's the website there, The Creative Educator. Don't forget and there's 2 E's in there. But you can if you just look up Creative Educator online, you should be able to find something like that, and you'll be able to find some data kinds of things there. And if you have any questions, you can reach out to me there. And I hope you enjoy. Thank you very much for joining me.